So far in our TRIADB Supplier-Part-Catalog demo, we have seen add operations. We started with a clean framework environment and gradually we added a data model with entities and attributes, the corresponding data sets, flat file data resources with tables and columns, and finally we stored records in the form of rows. In this video we continue our demo with get operations. The Python Jupyter notebook you see here is located under the get Supplier-Part-Catalog folder. Let the show begin. Like in the previous demos, we restart and clear all output cells. We connect TRIADB to InterSystems Cache server and execute the first get command. The output is a pandas data framework that displays an overview from the data types environment, abbreviated as DTE, and represented with a key starting with environment dimension equal to 11. This is a container for several type systems that have keys with system dimensions set to 1000, 2000, 3000, etc. For an in-depth view of entity type system, we pass again the appropriate from and what keywords arguments in the next get operation. And we take all the entity types defined in TRIADB framework that are represented with keys that have a common environment and system dimensions. And we do the same for the attribute type system. We also have other types for the DBMS environment. And we use hyperlink types for the bidirectional edges of our hypergraph. In the current type system, there are 150 hyperlinks of type hyperbond hyperatom. These connect record references with atomic value references. Another 17 hyperlinks are used to connect entities with attributes of the data model, and the same number is used to connect tables with columns. In the next get operation, we read the primitive type system. Each of these primitive literal types is a set of data values that are stored with the corresponding native primitive data type of InterSystems Cache DBMS. So this becomes more clear with the next get operation from the data values environment, where we fetch all the real values of TRIADB. And this is InterSystems Cache object script code written for the DBMS server that implements TRIADB real primitive literal type. This not value property here is using InterSystems Cache double native data type to store real numbers. And this unique index on the same property characterizes that class as a set container of single instance values. This becomes apparent if we observe the value column of this pandas data frame. In a similar way, we can retrieve all single instance integer values and do the same for text values, word value, shorter length word values, named values for categorical variables, and dates in the orolog format of InterSystems Cache. Now we change to data resources environment. Among other things we get is the full path of the flat files that we used in a previous demo to add records. From the same environment we pass the key of the data resource and we get an analytical view that shows how the 3 tables and their 17 columns are mapped onto the entities and attributes of the data model, and consecutively on TRIADB data sets. If we use a third keyword argument on the get operations, we can be more specific on what we ask to retrieve. For example, get tables only, or get columns only, or view both tables on the left side and columns on the right side, their mapping and the hyperlinks that show how they are connected. Alternatively, we can also read the rows of each flat file on the disk. This data frame is for the catalog table, this one for the parts table, and this one is for the suppliers table. Switching to the data modeling environment, we can view information about the data model we created from JSON files in that folder. Get an analytical view of this specific data model with its entities and attributes and mapped data sets, or similar to the data resources environment, we can use what keyword argument to ask for entities, attributes, and hyperlinks. We can modify the with ID keyword argument and focus on a specific entity. The catalog, for example, display all the hyperbonds. That means all hypercollection of references to catalog records, and change also the display format to key value pairs. This time we repeat these get operations for an attribute. This supplier ID is a common attribute of a specific supplier and his catalog entries. We can retrieve the hyperatom references to the values of the field and change the display format to key value pairs. Another example, to display the set of hyperatom references and values for the catalog total attribute and obtain the same output as a list of keys only. And this is the hypercollection of catalog check attribute and its values that we can take back as a list. All hypercollections that we saw in data modeling environment are actually retrieved from the data sets environment. In the Supplier-Part-Catalog data set, we have 3 hyperbond collections and 15 hyperatom collections that correspond to the mapped entities and attributes of the data model. With the next get operation, we can view all hyperatom value sets, and we can also specify to return only those sets of a specific primitive data type. For example, enum hypercollections and word hypercollections. We can see each of these hypercollections in more detail by passing their key to with ID keyword argument. This is the hyperatom collection for supplier ID. Notice that this is exactly the same output we saw before when we applied get operations on attributes. And this one is for catalog total, and this one is for catalog check. And that concludes our demo on get operations of Supplier-Part-Catalog use case.